is when we start with an x value of 4, we end up with a y value of 2, so that would be an ordered pair. When I plug in 4, I get 2, then that way you have a second ordered pair, and as soon as you plot that second ordered pair, you can connect the dots and form a line out of it. So 4, 2 would be right there, and then you can just connect the dots. Okay, so that line would look like that. Your alternate methods, that was method number 1, and this is a pretty rare scenario, like if your x and y intercept both end up being 0. Your other option is to rearrange this equation and get it into y equals mx plus b, because I know there are a lot of people that are just more comfortable in y equals mx plus b, and that is totally fine. So what you would do with this is, if we start with x minus 2y equals 0, you can start by subtracting the x from both sides, and you end up with negative 2y equals negative x, and you can write plus 0 if you want. I'll show you in a moment why that might not be the worst idea, to actually leave the 0 in there. And then next thing, we're going to divide both sides by negative 2, like that. So then we get the y by itself. This is technically a negative 1 in front of the x, so you have negative 1 over negative 2, which reduces down to 1/2 times x, and then anything you divide 0 by still comes out to be 0. So this is now in our mx plus b form. So remember, this is the slope, that's m, and then this is the y-intercepts. So if you're looking at the equation, 0 is the y-intercept, which means it goes right through the origin. And then this means that our slope is 1/2. So from our intercept, we go up 1 to the right 2. So you can see we'd go up 1 to the right 2, up 1 to the right 2, and we end up with the exact same line, no matter which technique you're using. And what I normally do with a grid is I just kind of keep that pattern going until you take up the whole grid, because we need accuracy in order to figure out exactly where the intercept is going to be. Okay, so here, instead of going up and to the right, you could also go down and to the lefts, and just keep that pattern going until you filled up the whole grid. Okay, so that's the first line. That one was tricky because the x and y intercept were both at the origin, so we had to do some sort of alternate method. All right, this one is in y equals mx plus b. So from that form, it's actually pretty easy to plot. So we start with this number right here, the negative 3. And the negative 3 tells us that our y-intercept is right down there at negative 3. So you always start with that point. If you're in y equals mx plus b, b tells you the y-intercept, start at that point, and then you go from there. So this becomes kind of like your starting point. And then our slope is 2, which is like 2 over 1. So from this point, we go up 2 to the right 1, up 2 to the right 1, and like I said, just kind of keep that pattern going until you fill up the whole grid. And then connect the dots. Okay, so those are our 2 lines. We graph them, they're just equal signs. If they're equal signs, then they're solid lines, there's no shading. What we're looking for here is where they intersect each other. So you see right here is where the 2 lines intersect. There's only one point that both of these lines have in common, and if you pick out that intersection point, that's going to be your final answer. So this intersection point right here is 2 units over on the x-axis and 1 unit up. So your final answer would be this ordered pair where the 2 graphs intersect each other. Okay, questions on that one? No? All right. So next one is the substitution method. So we still have the same end goal. Our end goal is to figure out what ordered pair works for this equation that also works for this equation. On the test on Wednesday, I'm going to very specifically tell you what method to use. Even if you get the right answer using a different method, you're not going to get much credit for it. You might get like 1 point for having the right answer, but my test is on the actual different methods, so you need to know how to do them all. So if I tell you substitution method and you use elimination method, I don't care if you get the right answer because you didn't use the right method to do it. All right, so substitution, your first thing is you want to get one of the variables completely by itself. So isolate the one that looks like it's almost by itself already, and that would be this letter D in the second equation. So it's easiest to get that one by itself. All right, so to get D by itself, you're going to add 2B to both sides. Okay, so add 2B, so it'll cancel over here. So we end up with D equals 1 plus 2B. Okay, so an equal sign literally means just that. It means the left-hand side is equal to the right-hand side, which means that D is equal to 1 plus 2B. So the logic behind the substitution method says, if I can write this D as 1 plus 2B, why not write this D as 1 plus 2B? that's what you do, is you take the expression that you got and you literally sub it into the other equation. Okay, so the d that we have in the first equation, we're gonna replace it with 1 plus 2b. So that'll look like this. So I'm writing my first equation. I have 4b minus 2 times d, but instead of d, I'm gonna write this expression, because this expression tells me that I can. It tells me anytime I have the letter d, I can replace it with 1 plus 2b. And then finish off the equation, equals 5. So it looks like that. So I literally replace the d with a 1 plus 2b, and then you're gonna keep simplifying. Left-hand side, do some distributing, combining like terms. So we have 4b, and then here I have a negative 2 that I can distribute to both of those terms. So I have negative 2 times 1, which would be negative 2, negative 2 times 2b, which is negative 4b, equals 5. So on the left-hand side, if I have 4b minus 4b, what happens there? They cancel. Yeah, 4b minus 4b would just be 0. It's not b. I saw a lot of people that just wrote b. It's not. 4b minus 4b is 0. It's gone. So I end up with negative 2 equals 5. What does that mean?
No solution.
Means there's no solution. Good. Negative 2 does not equal 5. So that means that no matter what you do, you're not going to get a solution to this problem. So it ends up being no solution. What if you got to the end and it said negative 2 equals negative 2? That would be infinitely many solutions. Good. So you guys could see either one of those scenarios. If you have variables, you're going to get an ordered pair. Like if your variables didn't cancel, you would eventually end up with some sort of ordered pair, like we did in the first one. If your variables completely cancel out, one of two things will be true. Either it's no solution or infinitely many, depending on your very last equation that you have here. So a false statement like this would be no solution. All right. Let's do elimination method next. So we're going to get lots of practice with elimination method. This one, elimination, literally means we want one of the variables to cancel out. Pay attention to which one's going to be easier. Here, the 8 and the 10, it wouldn't be impossible, but you'd have to multiply them both. And if we can multiply just one of them rather than both of them, we would choose that. So here we've got 3y and 6y. So we can leave this one as a 6y if we're able to turn this one into a negative 6y. So eliminating means we have a positive 6y, we want to get it to cancel with a negative 6y, and then it would eliminate. So I'm going to take this whole equation right here, the top one, and I'm going to multiply it all by negative 2. Okay, because I can't just multiply the 3y by a negative 2, I have to multiply everything. So multiply everything by a negative 2, and that becomes negative 16x minus 6y equals positive 10. So that's what happens when I take this top equation right here and multiply everything by negative 2. So the second equation gets to stay. It had a 6y works for us. So just leave it like this, but start to combine everything up. So 10x minus 16x would be a negative 6x. The y's cancel, which is good. That's exactly what we were hoping would happen here. And then negative 13 plus 10 would be a negative 3. So that's the equation that you guys should end up with once you eliminate the y's. Now again, you could have made the x's cancel out. It just would have been a little bit more complicated. You would have had to multiply both equations. So to get the x by itself, divide both sides by negative 6. And this reduces down to positive 1/2, not positive 2, because the larger of the numbers is in the denominator. So it reduces down to positive 1/2. So that's x. Then x gets subbed back into one of these equations, and you can solve for y. So choose either one, doesn't matter. Let's say I go into the first one, just because those numbers are smaller. So 8x, we would have 8 times 1/2. I'm going to replace the x with the 1/2, plus 3y equals negative 5. And now this will allow us to solve for y, and then we'll have our ordered pair. Okay, so this 8 times 1/2 is 4. So we have 4 plus 3y equals negative 5. And then subtract 4 from both sides. So now we have 3y equals negative 9. Divide both sides by 3. So this ends up with y equals negative 3. So remember, it should always be an ordered pair. Ordered meaning the x value goes first, y value goes second, and then that would be your answer. Okay, how are we doing on those three? Any questions on solving by graphing, substitution, or elimination? No, okay. So flip to page 4. So starting with page 4, we've got inequalities. Inequalities should always be shaded. So the way to spot these, if I say solve this by graphing, because the only difference between number 1 and number 4 is that number 1, those were equations, and number 4, these are inequalities. So if you see less than, greater than, less than or equal to, greater than or equal to, you guys should be shading. So you still know how to plot the actual line, but you should also be shading any one of those that you see. So starting with that first one. I'm just grabbing crayons, don't mind me. All right. So that first one, these are both in standard form, and I'll show you two different options. You can either leave it in standard form and plot it that way, or if you're more comfortable converting it into slope-intercepts, you could do that. So I'm going to show you both. First one, we're in standard form, so you can solve using x and y intercepts. So to find our x-intercept, we just plug in 0 for y. So if you plug in 0 for y, you just see x equals -2, and that would be your x-intercepts. And so that would be this value right here. And then we do the same thing for x. So to find our y-intercept, plug in 0 for x. And then we can see that our y-intercept would actually also be -2. Okay, so -2 would be right there. Next, take a look at the inequality symbol. It's just a greater than, not a greater than or equal to. So just a greater than means it should be a dotted line. So plot a dotted line going through these points. If you forget to do that on the test on Wednesday, just make me a note. It happens all the time. Just make me a little note that says, like, oops, this line should be dashed if you didn't use a pencil. All right, and then we do a test point, because remember, inequalities should be shaded somewhere. So either all of this stuff over here is your solution, or all of this stuff down here. So test any point that you want. We use the origin, because the origin is super easy to check. Okay, so plug in for our test point, 0 plus 0 is greater than -2. Is that true or is it false? Is 0 plus 0 greater than -2? That is true. Yes, 0 is in fact greater than -2. So what that means is that we're going to shade this region up here. Okay, so the 0, 0 ends up being part of the shaded region, which should be this up here. I just reached my hand into the crayon box and somehow ended up with literally 4 different shades of brown. Good, so that's gonna be a nice pretty inequality that we're shading. Next one, okay, so I wanna show you an alternate method for this next one. You can do x and y intercepts if they're in standard form, and that will work. You could also, if you wanted to, just convert it into slope intercept form. So I'm gonna show you that with the second inequality. Okay, so this one, instead of leaving it in that form, we're going to convert it into slope-intercept form. Okay, and either method will work. You can mix and match if you want. I know some of you guys express being just more comfortable in slope-intercept forms. You want to change it every single time. That is fine. Okay, so this, if we have 3x minus y is greater than or equal to -2, we want to get y by itself, so we eventually want just y on the left-hand side and everything else on the right. So that's what we're aiming for. So start by subtracting 3x. So this will cancel, and we have -y is greater than or equal to -3x minus 2. So that's at least in the right order, like y, mx, b. The issue here is that that y cannot be negative if we want it to be our final inequality. So we're going to divide everything on both sides by a -1. What do you have to remember if you're dividing everything by a -1? Flip the sign. Good. So instead of greater than or equal to, this will switch to less than or equal to. And then our -3x becomes +3x, and our -2 becomes +2. So that would be your equation if you want to convert it. You don't have to convert it. You could do x and y intercepts again, just like we did with the first one. But if you guys are more comfortable with this form, it'll work every time. So we start with this number right here. That number that's hanging out on the end is going to be our y-intercepts. And so we go up to 2, plot a point right there. So that's our y-intercept of 2. And then our slope is 3. So it's like 3 over 1. So you go up 3 to the right 1, and you start from this point. Like once you plot your y-intercept, you start from this point, and you go up 3 to the right 1. You can also reverse the process and go off the other way like this. Okay, if we look at our symbol, we have less than or equal to. The or equal to means that it's going to be a solid line, like this. And then the last thing you're going to do is do a test point. The line doesn't go through the origin, so we can test the origin. So if we plug in 0 is less than or equal to 0 plus 2, is that true or false? True, good. 0 is less than or equal to 2. So that means that 0, 0 should be shaded. So this is going to be part of our shaded region right here, which means we do everything over in this part. Okay, so here's what that means. These two inequalities, if you plug in different ordered pairs, the inequalities either come out true or false. So what we're trying to figure out is what ordered pairs would make this one true and make this one true. Like this region, the region that's just yellow, only made the first one true. It would have made the second one false. And the region down here that's just pink, it would have made the second one true, but it would have made the first one false. This is the region that we care about over here. This is the region that's our solution because it would make the first one true and the second one true. So please make sure that that way is in some way emphasized. Make it darker, make it a different color, do something with it so that it stands out as being the overlapping region when you're done. Because you need something, it's not, you can't put like an ordered pair in a box and circle it up. You need to emphasize that this is your final answer in some way. Okay, so darker, different color, whatever you want. Okay, so that's 4. That's just plotting a system of inequalities. 5 and 6, you're still plotting inequalities, but we start to add new steps to it every time. So in number 5, you're plotting, but then the last thing they want you to do is find the vertices of the triangle. Okay, so we start with the plotting, and then step 2 is finding those vertices. So let's go through piece by piece. This one right here. The top one is in slope-intercept form already. Okay, so our y-intercept is 1, so you can go up to 1, plot a point right there. And then our slope here, when you have a negative in front of the x, that means your slope is -1. So from this point right here, do a slope of -1, which means going down 1 to the right 1, down 1 to the right 1, and just repeat that process throughout the whole grid. If we're finding vertices, we need it to be accurate. So you need to make sure that you're actually plotting every point throughout the whole grid so you know exactly where the intersections are going to happen. Okay, it's a greater than or equal to, which means it is going to be a solid line, like that. And then we can test the origin. The origin is not on the line, so we can test it. So we have 0 is greater than or equal to 0 plus 1. Which it is not. 0 is not greater than or equal to 1. 0 is less than 1. So this is false. So what that means is that 0, 0 should be in the unshaded region because it came out to be false. That just means you shade the opposite part. So that would be this part up here. Okay, next, this one. Also in slope-intercept form, your y-intercept is -1, so start there. Right there at -1. And then your slope there, that's just an x. So if you just see an x, what's the slope? 1. Good, so that means from our y-intercepts, we go up 1 to the right 1, up 1 to the right 1, and just fill up that whole grid. Okay, we have less than or equal to, so that means that the line is solid. And then we can use 0, 0. The only time we can't is if it literally runs right through the origin and 0, 0 is actually on the line, which it's not here. So if we test out 0 is less than or equal to 0 minus 1, that's actually also false because that comes out to be 0 is less than -1, and it's not. So again, if you come up with a false statement like that, that just means that 0, 0 should be unshaded. So shade in the opposite direction. So that would be like this over here. Okay, so we got a little more practice with the y-intercept form, slope-intercept form. What about these ones? What if it's just x and your equation doesn't have a y? What does that end up looking like? Yeah.
Just a straight line.
What kind of straight line?
Straight line.
I think, yeah, so you're doing it with your hands, but what is this? Vertical, yeah, so we've got vertical or horizontal. So this, we know that the x value is 3, and what we know about that line is that the x value is always 3, no matter what the y value is. So go over 1, 2, 3, and you're definitely gonna have a point right there. But if we know that the x value is always 3, that means you just go straight up and down. Like here's 3, 0, 3, 1, 3, 2, 3, 3, like all the way up and down this line right here. The x value is always 3. So if it's just x, it always turns into a vertical line. If it's just y, it's a horizontal line, which we have some of those on the next problem. Okay, so then we test 0, 0. There's only one place to plug it in. 0 is less than or equal to 3. And that is now true. So that means for this last one, we shade in the direction of the origins. That would be this direction over here. So we end up with just this triangle in the middle where everything is shaded. So that's going to be your overlapping region in the middle here. Okay, so that's, I used pink and blue and yellow, so that triangle was overlapping pink and blue and yellow. So that would be your final region. Again, make sure it's emphasized in some way that that's the overlap and that's the darkest part. And then it says find the coordinates of the vertices. So the vertices are all the different intersection points. So we have an intersection point right here. We have another one right down below it, and then we have another one right here. So we want to identify those, and those are going to be ordered pairs. So this one right here, this is the ordered pair 3, 2. So we've got that one. The one directly below it is 3, -2. And then the one right here on the far left corner of the triangle would be 1, 0. All right, questions on either of those? Okay, go ahead and flip to number 6. We're doing more inequalities, more vertices, and then we've got one more step at the tail end of this one. All right, so the first part says start by graphing the system. So we're gonna graph the system. First one, y is greater than or equal to 2. So if it's just y, that's horizontal. So we go up 1, 2 on the y-axis. There's our y-intercept, and then we just turn it into a horizontal line. It is solid because this is greater than or equal to. And if we test the origin, 0 isn't greater than or equal to 2. So that means we shade above it. Because we're looking for any y values that are bigger than 2. These are the y values that are equal to 2. And if you go up above, these y values are 3, 4, 5, etc. So that would be everything above that line. Bless you. Bless you. All right, so we got that one. Next one, just x, which means they're vertical. If you see these, this is in between these two values. So you start with an x value of 1 and then go to an x value of 5, and it's just 2 vertical lines. So it ends up being like a little strip of the x-axis. So here's a vertical line at 1. Here's a vertical line at 5. And then our shading ends up being everything in between those values. Okay, so we got that one. And then the last piece is this one right here. That one's in slope-intercept form. Our y-intercept is 3, so go up 1, 2, 3 and plot a point right there. And then your slope is 1. Technically, if there's nothing written in front of the x, that slope would be 1. So you start at your y-intercept right there, and then from that point, go up 1 to the right 1, up one to the right one, and just carry that through the whole grid. Make sure you go high enough. So we're going just one more, up one, over one. I apologize for that going off the grid. And then connect the dots with a solid line. Okay, and the last part here would be where we're shading this. So if you plug in the origin, we get 0 is less than or equal to 0 plus 3, which is true. 0 is less than 3. So that means that we're shading everything like below this line. Okay, so here's what we end up with. Our graph is bounded below by this horizontal line. It's bounded on the left and on the right by these vertical lines, and then it's bounded above by this line. And then it's everything in the middle. So it's like this little trapezoid region in the center. It's not a triangle. It does not go all the way out to here because it's bounded by this vertical line. Okay, so we've got horizontal, vertical, vertical, and then a diagonal line right here. And that's your overlapping region. So it should be a trapezoid. It should not be a triangle that goes all the way out to here because it's only in this little strip down the middle. Okay, so next thing, if we follow the directions, graph the system of inequalities, got that. Next, name the coordinates of the vertices. Okay, so that's what we're doing next, is we gotta pick out those vertices. So we have 4 points. 4 lines means 4 points. So we've got a point here, down here, over here, and up here. So let's go this one right here. This is 1, 2. The one right above it, if this is 1, 2, then this is 1, 4. And then over here, this is 5, 2, over 5, up 2. And then the one all the way up here, this is 2, 3, 4, 5, 6, 7 is where the grid ends, but then we went up 1 and over 1 just one more time. So that would be 5, 8s. Okay, so those are the steps that we already did on a problem like number 5. We plotted the inequality. Next step was to do the vertices. Last step is something that's new to this problem, and that is finding the min and max values, and that's where this function right here comes in. Okay, so we have a function where you can plug in x's and y's. You take turns plugging in these points into this equation, and then you pick out the biggest and smallest values. Okay, so plugging in 1, 2 first. So you'd have 3 times 1 minus 2 times 2. So that would be 3 minus 4, which is negative 1. So that's the value we get from our first ordered pair. And then plug in 1, 4 next. So 3 times 1 minus 2 times 4. So that would be 3 minus 8, which is negative 5. And then same thing with the next two pairs. Our next ordered pair is 5, 2. So we have 3 times 5 minus 2 times 2. That would be 15 minus 4, which is 11. And then our last one, we plug in 5, 8. So 3 times 5 minus 2 times 8. And that would be 15 minus 16, which is negative 1. Okay, so your goal is the lowest and highest values. So the maximum value, the largest that we ended up with, was 11. And then the minimum value, the very smallest one, was negative 5. So that would be your final answer, is the largest and the smallest value that you get off that table. Okay, all done with the inequalities. Questions on any of those? No. Okay, so 7 and 8 are from 3-4. These are these systems of 3 inequalities. So the first piece of advice I'm going to give you is to pick one of the variables that's kind of by itself. And we actually have all of them. So we have like x is by itself here, y is by itself here, z is by itself here. So you can make any of those work. Let's just say, let's start with x. All right, so this, if we label this A and B and C, that way we know which ones we're talking about instead of like naming the entire equation. So our goal, we need to do 2 different eliminations. We're gonna get the x's to cancel out both times. The x's have to cancel out both times, otherwise we're gonna mess ourselves up. All right, so first, look at this one right here. That's a 2x. Okay, so A has a 2x. What term will cancel with a 2x? What will cancel with a 2x? Negative 2x. So we need to turn this middle one into a negative 2x. So what we're going to do is multiply the whole equation by negative 2. Okay, so we're going to leave equation A the way it is. And then we're going to multiply equation B by a negative 2. And that way we'll have a positive 2x and a negative 2x, and we can get those to cancel out. Okay, so I'm just going to write equation A just the way it is. And then lined up right underneath it, I'm going to do equation B, but I'm going to multiply everything by a negative 2. Okay, so x times negative 2 is negative 2x. Negative 2y times negative 2 would be positive 4y. Negative 4z times negative 2 would be positive 8z. And then 14 times negative 2 would be negative 28. Okay, so x's eliminate, which is good. That's what we needed to happen. And then we add the y's, we get 7y. Add the z's, we get 7z. And then 0 and negative 28 would be negative 28. And then label that equation D. We're going to come back for that equation in our next round. Okay, so I just did the elimination method once. I got the x's to cancel out. When I do the elimination method again, you have to get the x's to cancel out again. If you try to cancel a different variable out, it's going to mess you up in your next step. Okay, so it has to be x's again. And this time we have to use equation C because we haven't used it yet. So equation C has a 3x. All right, what term will cancel with a 3x? Negative 3x, good. So because this x is by itself, that's why we choose one that's by itself, so you can easily manipulate it and multiply by anything you want. So if we multiply that x by a negative 3, then we'll get a negative 3x, and it'll cancel with our positive 3x. So we're going to leave C this time exactly the way it is, and then we're going to multiply B this time by a negative 3. All right, so here's equation C, just the way it is. No changes made to it at all. And then I'm going to run through equation B, multiply everything by negative 3. So x times negative 3, negative 2 times negative 3, negative 4 times negative 3, and 14 times negative 3. Okay, so that's my whole second equation all scaled up, multiplied everything by negative 3. So these cancel. And then y and 6y gives me 7y. My z's, I will have 4z equals negative 25. So that is E. Okay, so before I go into my next round, any issues with doing the elimination twice, ending up with equations D and E? Yeah.
What if I use a different way and I got like...
Yep, oh, there's so many different ways that you could do this. Yeah, this is just me choosing x's. So if you had chosen a different variable, or if you had chosen different combinations, there's tons of different ways to get to the same answer. Okay, so now guys, we have D and E. You need to pick a different variable to eliminate. So we can either next eliminate the y's or eliminate the z's, either way. If we look at the y's, these are definitely the way to go here, because this is already a positive 7y, and this is a positive 7y. We just need to make one of them negative, and it doesn't matter which one. So let's say we make equation D negative. So we're going to multiply all of equation D by a negative 1, and then just combine that with equation E. That way this will be a negative 7y, and this will be a positive 7y, and they'll cancel out. Okay, so multiply everything here by a negative. So I have negative 7y, negative 7z, and that would be a positive 28. Okay, so that's my negative version of equation D. I'm going to line up equation E right underneath it. Okay, y's cancel. For z, I end up with a negative 3z equals, and this is 3. Okay, so now to get z by itself, divide both sides by negative 3. And I end up with z equals negative 1. And that's one of my values. Once you get one value, the hard part's over. Because then you're just kind of subbing back in. Like this is the hard part. Once you have one of these variables, you can just start plugging back in. So now Z will get plugged into one of these. Like once you get your first variable, you go into one of these equations. Let's go into E, so the numbers are slightly smaller. So plug Z equals 1, -1 in right here for Z. So we get 7y plus 4 times -1 equals -25. Okay, so then our equation looks like that. So to get y by itself, we're going to add 4. We get 7y equals -21. And then divide both sides by 7, and we end up with y equals -3. So that's 2 of our 3 answers. We still need x. To get x, we're going to go all the way back up to the top. Okay, so all the way back up. Let's do equation B, because the x is already pretty much by itself there. Okay, so you could do A, B, or C. There's so many different combinations of how to do this. So I'm not showing you like the one and only right way. I'm just showing you one possibility. So plug in y equals -3 and z equals 1 into equation B. So we have x minus 2 times y, and then minus 4 times z equals 14. So this is x, this becomes plus 6 plus 4 equals 14. So we have x plus 10 equals 14. And then if you subtract 10 from both sides, we end up with x equals 4. Okay, so our ordered triple, put it as x and then y and then z. And that would be your final answer. An ordered triple like that. Piece of advice for Wednesday, you should not have nasty decimals. Okay, I will not give you one that has fractions or decimals. All right, so expect integer values like this. If you don't have integer values, look back and see if there's like a negative sign or something weird that you did wrong. Okay, let's flip to 8. 8 comparatively should have been much easier. All right, so this one, number 8, see how the z is the only one that's by itself there? I would go with z. So we're going to do some sort of combination. So if you look at equation A, we say A, B, C. Equation A has a -2z. So to cancel with a -2z, we need a positive 2z, so we can manipulate this into being a positive 2z. So we're going to leave equation A just the way it is. But since we want this to be a positive 2z, we're going to multiply this equation by a -2. Okay, so that's equation A, not making any changes to it. And then I'm going to line up equation C after I multiply it by -2. Okay, and then 2y times -2, -z times -2, and 4 times -2. So a lot of you guys were freaked out by this while you were working on Wednesday and Thursday. What happens here is literally everything cancels. So the left-hand side leaves you with nothing. The right-hand side leaves you with nothing. What does that mean? Infinitely many solutions. We talked about this on the front with the one that turned out being no solution. If you end up with a false statement, it's no solution. If you end up with a true statement, it's infinitely many solutions. And then, of course, if you end up with an answer, then you get an ordered pair or an ordered triple. Okay, that's through 3, 4 now. 3, 5 starts our matrices, and that's number 9. So this one, when you're adding or subtracting, you need the matrices to be the exact same size. So please pay attention. Just look in between them. Make sure you know whether you're adding or subtracting. For this one, when you're adding, you literally just piece together every corresponding pair. So for instance, the upper left-hand corners go together, the upper right-hand corners go together, and you're just pairing up element by element and just adding them together. Okay, so this, we have 2 plus -6, which would be -4. -1 plus 9 is 8. And then do the same thing in the next 2 rows. 3 plus 7 is 10. 7 plus -11 is -4. 14 plus -8 is 6. And negative 9 plus 17 is 8. So that's what you guys should have ended up with. That one should have been pretty straightforward. When you're adding or subtracting, you literally just go term by term like that. Okay. 10 is really similar. The one thing that 10 has is that you're also multiplying by a scalar. So let's start with 4b. So 4b, we take matrix B right here and just literally multiply everything by 4. Kind of like distributing. We call it multiplying by a scalar. So 4b, I'm going to multiply all 6 of these terms by 4, and that'll make a new matrix. Okay, so that's the matrix that you should have ended up with after taking all of matrix B and multiplying it by 4. It's like scaling it up. And then this says 4b minus A. So I'm going to write minus and just copy down A so that I have it in front of me. Okay, so be careful with the subtraction, especially when you're subtracting a negative, like minus a negative. Just pay attention to that. So this first spot, we have negative 8 minus 4. So that would be negative 12. And just carefully go through and follow that process for everything. 16 minus negative 1 would come out as 17. 20 minus 0 is still 20. 4 minus negative 3 would be 7. 0 minus 6 is negative 6. And the last spot would be 36 minus 2, which is 34. Okay, that's your 3-5 stuff. Questions on the start of matrices, adding or subtracting matrices? No? Okay. All right. Next page, this one, 11. Determining whether the matrix product is defined. This is now 3-6 stuff. Figuring out whether you're even able, bless you, even able to multiply 2 matrices together. And you look at their dimensions to do that. So this one, we've got a 7 by 4. So 7 rows, 4 columns. This next one, you've got a 4 by 3. 4 rows, 3 columns. So what you guys are looking for is these inside numbers here. I'm going to write them bigger so you can see. So one of them's a 7 by 4, one's a 4 by 3. You're looking at these inside numbers. If those inside numbers match, it's a go. When you're multiplying, not when you're adding or subtracting. They have 2 different sets of rules. So when you are multiplying, if these numbers match, then you're good to go. So for us, that would be a yes. Like, yes, the matrix product is defined. And then our dimensions are going to be the outside numbers. So we've got this number as the number of rows and this number as the number of columns. Okay, so yes, and the new product would be a 7 by 3. The same number of rows as this matrix and the same number of columns as this matrix. I would never make you do a 7 by 3. 3 is where we max out, like 2 by 3, 3 by 2, 2 by 2. That would be absolute torture to make you do a 7 by 3. So let's just set up number 12. We're not going to be able to multiply it. But let's look at the dimensions here. So this first one on the left, we've got 2 rows and 2 columns. So this would be a 2 by 2. This one on the right, we've got 2 rows and then 3 columns. So this would be a 2 by 3. So first question, are you able to multiply these matrices together for number 12? Yes, that's these inside numbers. They match, so that's a go. What are the dimensions going to be of this new matrix? 2 by 3. Good. So we know our new one's going to be a 2 by 3. That's where we'll pick up tomorrow. So all you guys need to bring with you is this practice test tomorrow. It's an F schedule, so we'll spend the rest of class going through this. If there's additional time, which I'm not sure, it's really, what, like 26 minutes once we get down to it. So I'm thinking it'll probably just be the rest of this. So you guys are troopers, just sitting there and listening. Hopefully some of this stuff is starting to sink in a little bit better. Remember, there is a review video on Edpuzzle, so you guys could watch that tonight or tomorrow night, and hopefully that will help you guys out as well. Any questions for me before we go?